So now we'll see matrices. So matrices are of two types: square matrix and rectangular matrix. So here n into n, and here m into n. So here both the elements are same. Here both the number of rows and columns are different in rectangular matrix. So types of matrix: row matrix. If there is a single row, it is called row matrix. If it is a single column, it is column matrix. Next is null matrix. Null matrix is where all the elements inside the matrix are zero. It is called null matrix. But now what is diagonal matrix? So in diagonal matrix, the condition it should be square matrix. Diagonal matrix does not apply to rectangular matrix. Here the principal diagonal element should not be all zero. Should not be all zero. Other should be all zero. That is A is equal to Aij where n into n because it is square matrix. If I is not equal to j, then it will be 0. If I is equal to j, then all should not be all 0. See here I is equal to j. If I is equal to j, then it will be 3. I is equal to j means Aij. Here the order row number and order number is given. So if A 2, if this is the condition, here I and j are same. So the value where there are this number are same, it will be 3. So it will be only exist in diagonal where A11, A22, A33. So here you will write 3 and other all should be written as 0. This is called a diagonal matrix. So here it can be also 3, 3 and 8. There is no law that says it should be same. All the elements should be same. Here the determinant is 3 into 8 into 3. That is 972. Next is upper triangular matrix. So here the condition is it should be a square matrix. The elements below the principal diagonal should be all 0. Rest should not be all 0. If A is a matrix, Aij n into n is equal to I is less than j below principal diagonals, meaning all the elements below principal diagonal where I is less than j, I is equal to j, this is the principal diagonal. I is less than j, it is above principal diagonal. So see here I is greater than j. So here I is these two, one is j. So I is greater than j. So this value should be 0. So here is equal to 0. If I is less than j, so here I is less than j, it could be any value. And if I is equal to j, it is principal diagonal. I is less than j, this is equal to 0. I is greater than, this is equal to 0. So all the elements below the principal diagonal should be 0 in upper triangular matrix. In lower triangular matrix, this is just opposite. This 0 should be above. So it is lower triangular. Next is equal matrix. A matrix will be equal to B if all the elements are same in both the matrix. It will be then we can say A matrix is equal to B matrix. That is Aij is equal to M into N is equal to Bij M into N. Aij N into N. So here Mn Mn Nn Nn it is same. So both the matrices are equal. So this is a numerical based on this. So here they have given two matrices where the elements are this. They are saying find x and y. So if these matrices are same, the first element, that is a11, will be equal to this a11. So this a11 will be equal to this a11. So here this a11 will be equal to this a11. So we can write x plus y is equal to 1. So x plus y is equal to 1. This element will be equal to this one, this element. So x minus y is equal to minus 1. So x minus y 1. By solving this, you can get x and y value. Next is identity matrix. Identity matrix, again condition is it should be a square matrix. The diagonal element should be always 1. So here diagonal elements are 1 and rest all the elements should be 0. This is the condition in identity matrix where ai is equal to j. So that is a11, a12, a13, 21, a31, a22, a32. See here I is equal to j. Here I j are equal. This should be equal to 1. Where I is not equal to j, it should all be 0. This is the condition. This is an identity matrix. This is the property. Identity matrix also can be written as in. So in is always 1. So if I multiply in into in into in into in, we will get in. If we take inverse of in, we will then also we will get in. If we multiply the matrix to in, we will get the matrix because the value of in is 1. So we will get 1 into a matrix, that is the matrix. So here this is the question, choose false statement. So see here I inverse I3 inverse not equal to I3. See I inverse is equal to In. Here n value is here n value. See here is 3, here is 3. So I inverse equal to In. So here they are saying if they are saying I inverse equal to In, here also it is same I3 inverse is equal to I3, but they are saying it is not. So this is false statement because this is true. Here they are saying In into matrix B. So anything into matrix B is matrix B because I4 is 1. So this is also true statement. This is also true. So I4 is equal to 4. This is wrong because In value is always 1. So this should be 1. So this is false. I3 is equal to 1. This is true statement. This is false. Since this is equal, so this is false. This is we will get here only B. So this is false. I4 we will get In1, so this is also false. This is only true. So next is scalar matrix. So again there is a condition, this only applies to square matrix. So diagonal matrix with diagonal elements k is equal to k. So here see they have given condition I is equal to j is equal to k. So wherever there is I is equal to j, we write k. Wherever I is not equal to j, we will write 0. So this is a scalar matrix. This here I can write determinant is equal to k raised to n. Next is addition of matrix. So there is a condition in this, the order should always be same. Then only you can add two matrix. So see here 2 into 3 order is there, here also 2 into 3. Only then we can add. For a rectangular, for square, both order should be same. So here we add this element to this first element, this element to this corresponding elements we add. So 1 plus minus 1 0, minus 1 plus 1 0, plus 1 minus 1 0. So after in last we get 0 value. See these are the addition properties. So if a is m into n minus b is m into n, then a m into n plus minus b m into n. So it is like saying a minus b is equal to a plus minus b. This is same thing. These both are same thing. Next is this equation is commutative. That means a plus b is also equal to b plus a. That is matrix a plus matrix b is also equal to matrix b plus matrix a. That's why we call it commutative. The opposite to commutative is associative. Associative means if a plus b, if we sum a plus b, then we add matrix C, it will be equal to matrix A plus matrix B plus C. So here we have sum b plus C, here we have sum a plus b, and then after that we have multiplied the third matrix. So this is associative. So here cancellation, a plus b is equal to a plus c. So if there are similar matrix in the equation on the both LHS and RHS side, we can cancel these two and write b is equal to c. Next is a plus 0, null matrix is always a. Sixth thing, if we write matrix A is equal to matrix B plus C, then if we take determinant of this individual matrices, so if we take the determinant of this and we take the determinant of B and C individually we have taken the determinant and add them, then this will not be equal. This will be here A will always be less or equal to B plus C. But if we take determinant of A and here we take determinant of B plus C in bracket, so we add first we first add the matrix, then we take determinant here. So this is valued, you can do this. See, determinant of A is equal to determinant of A plus B, but it will not be equal to the sum of the individual determinants. So here they have given matrix A is equal to A A1 plus A2 plus A3, and they have given the determinant of A is 7. So if in this condition A1 is given as this, A2 is given as this, A3 is given as this, they are saying they are saying check what is the condition. So determinant of A is equal to determinant of A1 plus A2 plus A3. See, we can do this. Determinant of A is equal to A plus B plus C, anything. So 1 plus 3 plus 3. See, we chose this option because here it is 7. So 3 plus 3 6 plus 1 7. So determinant is 7. So 7 to 7. But if they are given this as determinant of A, determinant of 2, determinant of A3, here you have to use this expression, because here it is individual determinants are given. So this statement you will use this statement, determinant of A equal to or less than determinant of B plus determinant of C. So here determinant of A is equal to or less than determinant of B plus C. So which we will check. Here it is 7. So the value on the RHS should be equal to 7 or less than 7. So this option is correct, as 7 is less and this is more. 7 plus 1, it is 9. 133 is also okay because the value of this becomes 7, and you can choose the equal also. This you can't take because 7 becomes greater here. 7 should be less on the LHS. 416 you can take because it is 11 and 11 is bigger than 7. So this is okay. Now multiplication of matrices. In there is one rule. If there is a matrix of order 3 into 4 and B 4 into 3, this column should be equal to this row. So here the first matrix 6 column should be equal to the row of the another matrix. So this should be same. Then only you can multiply, or else you cannot multiply. So number of column of first matrix should be equal to number of rows in second matrix. This is the rule of multiplying. See, this is the property. Matrix C is equal to matrix A m into n, matrix B n into p. So they are saying how much will be the total multiplication, number of multiplication in this, how much it will be. So there is a formula to find this total number of multiplication of element required in multiplication of two matrices is equal to m into n into p. So we just multiply m into n into p. So if m is 1 and this is 2 into 3, then 1 into 2 into 3. So if they are asking what is the total number of addition that are done in this equation, so there is a formula m into n minus 1 into p. So my multiplication properties. So if a into b, you got some value. Suppose the value is 2. Then b into a can come to or cannot come to. It is depend on the data. See here, b into a is not equal to a into b. Always. Sometimes it can be or cannot be. So it is not commutative. Associative. A matrix A into B into C. This we have taken. It will be equal to A into B bracket into C. This is associative. Distributive. A into bracket B plus C bracket close is equal to matrix A into matrix B plus matrix A into matrix C. This is distributive. It is like saying x into A plus B is equal to x into A plus x into B. This you will know.